Hello and welcome back. We've got another video. We are doing some index laws, it looks like. Let's have a look. Solve for x in the following equations. So I won't do all of these. I'll just do a selection of them. So let's have a look at A. 2 to the power of x equals 128. For a lot of these questions, it will help if we can get the base the same. So 2 to the power of x equals 2 to the power of something. So 128, that is a really good number for us because we can work that out. We can say that is 2 to the power of something. We got to think about it though. So 2 to the power of 1, that's 2. 2 squared is 4. 8, 16, 32, 64, 128. So that would be 2 to the power of 1, 2, 3, 4, 5. Oh, this is a 16. 1, 2, 3, 4, 5, 6, 7. So 2 to the power of 7. So now, because our bases are the same, our powers must also be the same. So x equals 7. Let me just explain what I mean by bases. This 2 here is the base of the power of x, and this 2 here is the base of the power of 7. So because those bases are the same, that means the powers must also be equal. So x equals 7. Let's have a look at b now. B is a nice one. 3 to the power of x equals 9. Again, we want the bases to be the same, so 3 to the power of x equals, this 9 is what we want to change. That is 3 squared. So our bases are the same. That means we can say that our powers are the same. X equals 2. Nice. C now. Oh, I like how they increase the difficulty with these. This is really good. We've got 7 to the power of x equals 1 over 49. So 49, that's pretty familiar. We can work with that at least. 1 over 7 squared. The only problem is they're not the same thing. We don't have 7 equals 7. We've got 1 over 7 squared. So we're going to have to apply some index laws here. So we can make this 7 to the power of negative 2. So a negative power just means you could apply the reciprocal to the base, and if it's on the top, you can put it on the bottom of a fraction, or if it's on the bottom of a fraction, you can put it to the top of a fraction. So now our bases are equal. We can say that our powers are equal. X equals negative 2. Nice. Now I'll do D actually. D is quite a nice one as well. We've got 9 to the power of x equals 1. We want to make the bases the same. Let's see, 9 to the power of x equals 9 to the power of... How do you make a 1 with 9? 9... So I'll just do that over here maybe. 9 to the power of 1 is 9. 81. No, that doesn't work. I'm getting bigger numbers. So this is one of your index laws. 9 to the power of 0. That's 1. So 1 equals 9 to the power of 0. In fact, x to the power of 0 will equal 1, excluding x equals 0. But depending on what level of maths you're at, this is actually not true. But for what you're doing, it's probably fine to say x cannot equal 0. So our bases are the same. We can just say that x equals 0. That's it for D. Let's jump ahead now. Look at one of the ones with a square root in it. Maybe h. H looks nice. H. We've got 2 to the power of x equals 2 root 2. So this is the first time we've seen a radical symbol, a root symbol. We have to change that into a fractional power. So 2 to the power of x equals 2 times 2 to the power of a half. So that root symbol, that radical symbol, just means 1 over 2. It's a fractional power. If it had said, let me use a different color for this, the third root of 2, that would be 2 to the power of 1 third. That's all. Let's head back to this one now. So we've got 2 to the power of x equals 2 times 2 to the power of a half. Our bases over on the right-hand side are equal, and they're multiplied, so we can add the powers. We've got a 1 here. So 1 plus a half, that's 1 1/2, or 3 on 2. Our powers are equal because our bases are equal. So we can say x equals 3 on 2. And that's kind of it. We've got roots. We've seen this fraction before. We've got a few of those in n and o. We've got the combined with a root there. But you just want to make sure that you can get your bases the same. So maybe I'll have a go at f and j just to round this out. F is 64, x equals 8. Excuse me. So for this one, can I make 8 into 64, or can I make the 64 into 8? Or another thing I could do is, do they share a common base? They do. 8 is 2 to the power of 3. 64 would be 2 to the power of 6. And that is to the power of x. So powers of powers, we can multiply that. 2 to the power of 6x equals 2 to the power of 3. Our bases are the same. We can say the powers are the same. 6x equals 3. X equals 3 on 6, which is a half. And that's one method we could do. We could make the 2's the base for 64 and 8. Let's look at an alternative method. 64 to the power of x equals 8. 64 to the power of x equals 64 to the power of something. So what is 8 equal to in terms of 64? Well, 8 is the square root of 64, or to the power of a half. We saw that over in question H. So because our bases are the same, we can say our powers are the same. X equals a half. And we will of course get the same answer because x is the same in both. It's up to you which method you would prefer. Both are equally valid and they both give you the correct answer. So let's now look at J. J is the final one I want to look at for this video. So we've got 4 to the power of x equals 8. In this case, we can't get 4 and 8 in terms of each other. So we do have to look for a common base for both. And 4 is 2 to the power of 2. 8 is 2 to the power of 3. But of course, it is 4 to the power of x. So it'll be 2 to the power of 2 to the power of x. Because we're doing a power of a power, that's an index law, we can say it's 2 to the power of 2x. Just multiply the powers together. Equals 2 to the power of 3. Our bases are the same, so we can say our powers are the same. 2x equals 3. X equals 3 on 2. Alrighty, that's all the time we've got for today's video. Thanks for joining me, and I'll see you next time.